Hi all, welcome to the third video of our course Machine Learning Basics. So in this video we are going to learn what is feature extraction, what is overfitting and what is curse of dimensionality. So to start with, what is feature extraction? In the last video we have already learned what are features in machine learning. Features are the attributes or properties that define the data. So from the word itself we can say what can be feature extraction. Feature extraction means that is the process of transforming our raw data into meaningful features that we can use to build a machine learning model. So that is the feature extraction means simplifying the data, that is reducing the noise and improving the model performance. So as an example we can write converting the text to numbers. So in the last class we have seen what are features. In that we have seen this no C view can be written as 0, C view can be written as 1. In feature vectors we have already seen that. So no C views it's written like 0 and C view can be written as 1. So this is extracting the properties, meaningful properties from the data. That is what is known as feature extraction. That is transforming our raw data into meaningful features so that it can be used to make a meaningful machine learning model to improve the performance. Okay. Then the next term related to machine learning is what is known as overfitting. So overfitting actually means when we are giving a trained data to a machine learning model, the model learns not only from that trained data but also from its noise and irrelevant data. If the dimensions of our given data is very large, there can be many irrelevant details. So the machine learning model learns from all those irrelevant details from the training data, and what can be the disadvantage in this case? It can reduce the performance on unseen data or test data. So that is we can mark the overfitting like this. As the number of features or the properties or anything is increasing, and here we can write accuracy here. As the number of features increases, the trained data can perform like this. So accuracy increases as the number of features increases, but this can be the performance of trained data, but in the case of test data, it can be like this. The performance can drastically reduce if the number of features are extremely high. So that is high accuracy on training data, but poor accuracy on test data. This feature, that is what is known as overfitting. So how can we prevent this? This can be prevented by reduce the complexity of the model or reduce the number of parameters, reduce the number of independent variables. So by that we can reduce the complexity of overfitting. Hope this is clear to you. And the third term we are going to see today, that is the curse of dimensionality. That is directly related to the overfitting. As the number of features or the characteristics or feature vector increases, the volume of the feature space grows. That is, large amount of data will be there and it will be very hard to make a general model. It will be very hard for the model to generalize. So it increases the computational cost and it can reduce the density of training samples in the high dimensional space. So and it's also as the number of parameters or the number of features increases, it will be very difficult to find a general pattern as the data points are being so far. The data points will be distant so far apart, so it will be very difficult to find a pattern and make an easier or make a proper machine learning model. So it's always recommended to reduce the number of dimensionality, and we have many features. We have found out many algorithms to reduce the dimensionality, curse of dimensionality. One common procedure we are following is the principal component analysis. So this principal component analysis that reduces the number of dimensions and it can reduce overfitting as well as this curse of dimensionality. So in the coming sessions we will study all these things in detail. So for now we can stop here. So see you next session with more ML videos. Okay, thank you.